Assalamu alaikum, dear students. Today we are going to define here ampere, that is the SI unit of electric current. So here we will define this ampere in terms of the force experienced by current carrying parallel conductors. Now as we know, the force acting per unit length on two straight and parallel current carrying conductors, that is given by the relation F is equal to mu naught divided by 4 pi twice I1 I2 divided by R. So here I1 I2, these are the two currents. I1 is current through conductor first, I2 is current through conductor second, R is distance of separation between the two conductors. So here we have considered two conductors, conductor first and conductor second, separated by a distance of R. Both of these two conductors, they are carrying electric current. Conductor first is carrying a current I1, conductor second is carrying a current I2. Both of these conductors are held parallel to each other, separated by a distance of R. Now in that condition, they experience force. They experience force, and that force experienced by each conductor per unit length, that is given by this relation F is equal to mu naught divided by 4 pi twice I1 I2 divided by R. Now if current through each conductor is unity, means if current through conductor first is equal to the current through the conductor second, each equal to unity, means each equal to 1 ampere. And also if the distance of separation between these two conductors is 1 meter, then the force per unit length on each conductor is equal to F is equal to mu naught absolute permeability. Its value is 4 pi into 10 raised power minus 7 Tesla meter per ampere. This divided by 4 pi into twice I1. I1 is current through conductor first, that is 1 ampere, into I2, that is current through conductor second, that is also equal to 1 ampere, divided by R. R is distance of separation. So here distance of separation between these two conductors, here we have supposed it to be equal to 1 meter. Now this force per unit length, this force per unit length experienced by the each conductor, that will be equal to, now here 4 pi and 4 pi will cancel out, so here remains only 2 into 1 divided by 1, so that is simply 2 into this 10 raised power minus 7, 2 into 10 raised power minus 7 Newton per meter. So here this 2 into 10 raised power minus 7 Newton per meter, that is the amount of force experienced by each meter of each current carrying conductor, which are held parallel to each other, separated by a distance of 1 meter in vacuum. Now in terms of this force, we will define this ampere. So here we have obtained the force between the two conductors carrying current through them equal to unity, means 1 ampere, and separated by distance of 1 meter in vacuum. In that condition, they will experience a force of 2 into 10 raised power minus 7 Newton on each unit length of each conductor. So here from this equation, we can define this ampere as that much current. 1 ampere can be defined as that much current, which if maintained through each of the two conductors, which are held parallel to each other, separated by a distance of 1 meter in vacuum, they will produce a force of 2 into 10 raised power minus 7 Newton on each meter of the other of other wire or other conductor. Thus we can define 1 ampere. 1 ampere is that current which if which if maintained in two infinitely long and parallel conductors separated by a distance of 1 meter in vacuum, ठीक है ना, causes a force of 2 into 10 raised power minus 7 Newton, ठीक है ना, on each meter, or you can say on each unit length, ठीक है ना, of the other wire or other conductor, ठीक है ना. That is the definition of the ampere, ठीक है ना, in terms of this force experienced by the current carrier.